Okay, good evening, everybody. Today we're going to be talking about similar triangles and how we can use similar triangles and the relationship between the two triangles to solve some real-world problems. So, all right, so we look here, and first we've got to define what similar triangles are. So similar triangles have same shape but different size. Also, similar triangles have all angles. Let me change that. I want to say all angles. Similar triangles have angles are congruent. Meaning the same. Okay? So, the angles are going to be the same, but the sizes are going to be different. So there's a second thing that goes along with that. In addition to that, that means that the sides of two similar triangles are in proportion, meaning that there's a relationship to them. And we'll talk about that relationship later. Okay, so the sides aren't going to be the same length, but the angles will be the same. So one side might be 4, the other could be 8, something like that. All right, so take a look at the bottom here, and there's some notation we want to talk about. So here we have two triangles, and what this is saying is that the triangle ABC is similar to triangle A prime, B prime, and C prime. So I want to explain that in a second. So this symbol right here, A, and that little mark, like an apostrophe kind of, is called A prime. And it means that this angle is congruent to this angle. Those two angles are the same. And we use that little hash mark to say that those are the same. And then that means that B is congruent to B prime. And that also means that C is congruent to C prime. So that means that if A prime equals 30 degrees equals A prime, then A equals 30 degrees. The measurement of angle A equals 30 degrees. Okay? So if B, the angle of B equals 70 degrees, then B prime equals 70 degrees. Okay, so that means that these two angles are similar. If they're similar, that means we can use some things for them. Okay, let's take a look at the next slide. Okay, the next slide, we have similar triangles because these triangles are embedded. Now, there's a couple things we need to talk about. And the first thing we need to talk about is that this line right here, line AB, is parallel to ED. So line AB is parallel to line ED. That's important. For embedded triangles, these two lines here have to be parallel to each other. Okay? All right, now, they're embedded because embedded means one inside of the other, something inside. So we have a small triangle, which is triangle DEC. That's a terrible E. DEC is inside triangle, the big triangle, which is triangle ABC. So what you notice is that both of these triangles have an angle C. Here is the angle C for the small triangle, and here is the angle C for the large triangle. So since they both share this angle right here, and they both share this angle right here, and this line is parallel to this line right here, so these two lines are parallel, then that means that this is an embedded triangle and the two triangles are similar. So embedded triangles are always similar. Now, what that means is we can write a proportion. And what that proportion is that side AB over side DE is equal to any of the other sides that are in relation. So you could do side AC over side DC. Okay? And we'll take a look at proportions a little bit better. But so basically, I just make sure that in this case what I did was I did the big sides on top and the small sides on the bottom. Okay, so AB is a big side, so I put AB on top. AC is a big side, so I put AC on top. DE is a small side, I put that on the bottom. And then CD is a small side, and I put that on the bottom. Now, I wouldn't have used EC in this one because I didn't use BC. So you notice that I try and use the same sides in their location of their respective triangles. Okay? And again, we're going to talk about proportions quite a bit. All right, let's take a look at the next slide. All right, so lastly, we look at this one, and we see that we have two triangles that are like kind of connected at the middle. And if we ignore this right here, and we ignore this right here, that should remind us of something that we learned the other day. That this angle, whoa, I don't want to do that. This angle is, sorry people. What's going on here? Okay, let me try this again. If we ignore this, then we'll notice that this angle is what to that angle. And hopefully at this point you're saying that those two angles are vertical angles. So angle AEB is congruent to angle CED because they are vertical angles. Vertical angles. Okay, they're vertical angles. What I mean by that is that this angle right here is congruent to this angle over here. Those two angles are congruent because they're vertical angles. They're on opposite sides. We also use the word opposite angles. Okay, they're vertical angles. Now, if that's true, those angles are the same. Now, if we go back and I erase this right here and I put my original triangles back up there, now then what I have, then I have two lines that are parallel. I have this line here is parallel with this line here. So if that's true, if line AB is parallel to line CD, and these two angles are congruent because they're vertical angles, that means that these two triangles are similar triangles. Okay, these are similar triangles. And again, if they're similar triangles, that means we can write a proportion for them. All right? So I'm going to go ahead and write a proportion here for this one. So we have, here I see that I have AE is equal to 8. that means this one right here is equal to 8. So if I put small on top this time and big on the bottom, okay? So my small side is 8, and then I see down here AB, which is right, oh, darn it. Okay, I messed that up. Sorry, let me check that real quick. I just put that on the wrong spot. This is not, slowing down here. That is not there. That one is here. AE is this line right here. Sorry about that. And then this line up here, AB, is right here. Okay, so that's another small one. So then AB would be on the other fraction. So the smalls are on the top. The small side here is 10, and the small side here is 8. So those are both on top of my fractions. And then for my big fraction, I'm going to put, I see that I have ED, which is that right there. So ED is 16. And since the 16 is on the same line as this 8 over here, then I'm going to put the 16 with the 8, because they're along the same line right here. These are the same line. So the 8 and the 16 go together. And then what they're asking me to find is the length of CD, which is right here. So that I don't know. So I put an X there. So that means X is right there. And I've now set up my proportion. Okay, and we're going to learn how to solve our proportions. You may remember from last semester, circle and arrow, but I'll review that with us. Right now I just want you to set up the proportion. Okay, so similar triangles, they allow us to set up proportions so then we can start solving real world problems, which we'll be doing a lot of in class together. Okay, sorry about the mess up on this one. I'll try and clean it up if I can. If not, then I'll explain anything was confusing, and I will see you guys tomorrow. Okay, bye-bye.